In the last video, we talked about how to solve quadratic functions, find the solutions when the function is in factored form. You can use the zero product property. In this video, we're going to talk about a way to solve them when they are in standard form, as long as there is no x term. So when the function is in standard form with no x term, only an x squared and a number, but no x term, we can use a square root to solve for x. So that means if your function looks like this, normally in standard form we have f of x equals some number x squared plus some number times x plus some number. So we have a, b, and c, and those are all numbers. This only works if you don't have that middle x term. You only have an x squared term and just a plain number. If that's the case, then you can just use a square root to solve to get the solutions. So let's look at some examples of how we can use a square root, and I think just by watching the examples, it'll kind of make sense. So first of all, remember that when we want to find the solutions, those are at the x-intercepts, which happen when y equals 0. And remember, f of x is really just like y. So we're going to rewrite this as 0 equals x squared minus 9. Now if we can solve this, we can get the solutions. The first thing that you always want to do when you're solving with the square root is to get the x squared part all by itself. So in this case, we have to get rid of the minus 9. So the thing that we're going to do to undo the minus 9 is we're going to add a 9. So we're going to plus 9 on this side. And then we're also going to plus 9 on the other side, because in an equation, you always have to do it to both sides. So over there, it crosses out, and I just have an x squared. Over here, I have 0 plus 9, which equals 9. Now that you have the x squared all by itself, you're ready to use a square root, because now we just want to solve for x. But right now, we have x squared. We need to get rid of the squared. And the way that you undo a squared is you use a square root. So I'm going to square root this side and square root that side. So on the right side, the square and the square root cancel out, and I just have x. Now we need to talk about over here, the square root of 9. Immediately, what comes to mind is 3, right? So the square root of 9 would be 3, because 3 times 3 is 9. So we could say that x equals 3. However, there is another number that works too. Since a negative times a negative equals a positive, we could also say that in addition to 3 times 3 equaling 9, negative 3 times negative 3 also equals 9. So in this case, x could also be a negative 3. So whenever you take the square root of a number, you have to think, usually we just think about the positive square root. It's like the square root of 9 is 3, because 3 times 3 is 9. But we also need to think about the negative. The square root of 9 could also be negative 3, because negative 3 times negative 3 is also 9. This works really well this is really convenient for quadratic functions, because a lot of times quadratic functions have two solutions. This is where they come from. The fact that square roots can be the positives, or the solution to a square root can be the negative version. Now, in math, we like to keep things kind of efficient. So instead of saying x equals 3 and x equals negative 3, a lot of times we just write it like this. X equals positive or negative 3. That's what that means. We could say x equals a positive or negative 3, or a lot of times we call that x equals plus or minus 3. So that gives us our two solutions. So if we were going to graph this function, it would cross the x-axis at positive 3 and at a negative 3. Now let's try the next example. So we have, first of all, if we want to find the solutions, we set it equal to 0. Now our goal here is to first get the x squared all by itself, so that way we can use a square root. Right now it's being multiplied by 5. So I'm going to divide by 5 on both sides. So over there it goes away, and now I just have x squared. 0 divided by 5 is 0. So now we are ready to square root. So I square root that side, I square root that side. That cancels out, so I just have an x. Over there, the square root of 0 is 0 because 0 times 0 is 0, and that's the only thing for that one. There is no such thing as a positive 0 and a negative 0. So in this case, this one just has one solution, and it crosses at 0. So for example, if I were to graph this first one over here, it would look something like that, crossing at a -3 and a +3. This one just has one solution, and it's at 0, so it's right there. Crosses right there when x is, when x is 0. Now let's try this one. We have f of x equals 2x squared minus 32. If we're going to find the solution, remember the first thing we always do is we make f of x into 0 because the solutions happen when y is 0, the x-intercepts. Now I need to get the x squared all by itself. So I'm essentially just going to solve this for the x squared. First, I'm always going to undo the thing being added or subtracted. So I'm going to add 32 on both sides. So that cancels out. So now I have 32 equals 2x squared. Then I'm going to divide by 2 on both sides to undo the 2 right there. So that cancels out. So now I just have x squared. 32 divided by 2 is 16. So now to undo the squared, I square root both sides. So over here now I just have an x. Over here there's two ways to get 16. So I have a +4, or x could also be a -4 because 4 times 4 is 16, and -4 times -4 is also a +16. So for this I could write x equals ±4. For the last one, let's see what happens. So first, remember, we do this. We have x squared plus 25. And then I'm going to subtract 25 on both sides, because remember, my goal is to first just get the x squared all by itself. So on the right side, that cancels out. I just have x squared. Over here, 0 minus 25 is -25. Now I take the square root of both sides. So the question then is, what times what equals a -25? And the answer is, there is no such thing. Because 5 times 5 is a +25. -5 times -5 is a +25. And I can't do one of each. I can't do 5 times -5 because that's not what a square root is. A square root says it's like the same thing multiplied by itself. And +5 and -5 are not the same thing. So there is no such thing that you can multiply by itself to get a -25 or any negative number for that, for that case. So what we're going to do is we're just going to say nothing, no solution. So whenever you run into this situation where you're trying to take a square root of a negative number like that, that means that actually I'm going to say no real solution. Because there are things called imaginary numbers and imaginary solutions, but that is for your Algebra 2 days. That is not something we do in algebra. For right now, we're just going to say no real solution because this function is going to look something like that. It never touches the x-axis. So whenever you get a situation like this, you know that the graph is going to look something like that, and there's no real solution is what we're going to say. So that's how you solve functions using a square root. Remember, it only works if there is no middle term. You just have the squared and the plain number, and then you can use solving with square roots. Go ahead and try the practice, see how you do. Remember, you can always email me with questions, and yeah, good luck.